This is Physics 2 Lab 1, and I'm Lila Cheek. The introduction to this lab is that the purpose of the lab was to charge two pieces of clear tape and then to find the charges on those pieces of tape. We also found the deficit of electrons as well as the ratio of atoms to the deficit of electrons, which gave us a picture of how the electrons are transferred. Then a computational model was created to model the situation, first with the pieces of tape being treated as point charges and then with the big lines of charge. The physics principles that we need to know for this lab are Coulomb's law, which is this equation, which has constant charge of the first tape, charge of the second tape, and the distance between them. And then we also need to know Newton's law, which in this case, the application that we need is that when tape begins to float, the forces due to the electric field of the other piece of tape and the force of gravity are balanced and equal. And then the system in this lab is the tape on the top, and the surroundings are the tape on the bottom and the earth. The assumptions that we're making for this lab is that air resistance is negligible. For the experimental calculations, the pieces of tape were treated as point charges, and each tape has the same amount of charge, which this is a reasonable assumption to make because they're the same length and they were charged in the same way at the same time. So for the actual experiment, we charged two pieces of tape by placing pieces of tape on the table, then the other pieces were attached to that and quickly ripped off, and then they were charged. We ensured that the pieces of tape were charged by holding them near each other and near my hand. So we knew that if they repelled each other, they were charged, and if they were charged to my hand, they were charged. And then we measured how close one tape needed to be to the other in order to begin to make it float, and then we determined the excess charge based on those results. So our expected and observed results are expected results for that the tape should repel each other and they should be attracted to a negatively charged pin if they're positively charged and vice versa. And then our observed results for that the piece of tape did in fact repel each other and the pin and the tape were attracted, meaning that the tape has a positive charge, meaning that it has a deficit of electrons rather than an excess of electrons. So data and calculations, our most important data here is that the length of the tape, weight of the tape, and the separation distance between them when the top tape began to float. And then we used the area of the tape and the number of atoms to determine that ratio, which is listed right here. And then over here, we found that the charge on the tape is 2.066 times 10 to the negative 8 coulombs. And then this is the electron deficit. But the charge on the tape is really the number that we're looking for in the next computational model. So this computational model is part one, where they're treated as point charges. This is the code. We have the experimentally determined values as well as some constants. And then down here we find R, R mag, and R hat, which are needed for some of the equations to find out the different forces. So we found Fg first, which takes the tip of the mass, multiply that by 9.8, and then put that in vector form so that it's in the negative y hat direction. And then because the forces are balanced at this point, because the net force on the tape is 0, we know that Fe has to equal negative Fg, which is this line right here. And then we have to find the charge on one piece of tape, we use this equation right here. And then in this equation, we need to use the electric force that we found in a couple lines before. That code creates this model, which shows us the relative position vector, the force of gravity, and the electric force. So this is the gravity, and that's the electric force. And then we found that the charge on one piece of tape is 6.058 times 10 to the negative 8 coulombs. We will use this value in part two. So our comparison, experimentally, we determined that the charge on one piece of tape was 2.066 times 10 to the negative 8 coulombs, and in the model we determined that the charge was 2.0658 times 10 to the negative 8 coulombs, which are essentially identical. But to use this model, we had to treat the tapes as point charges and ignore air resistance, so this could lead to discrepancies between the two numbers, but mine turned out very close. And then the computational model part two produces this model where this is the top piece of tape and this is the bottom piece of tape, and they're treated as lines of charge, as you can see, rather than just one point, which has this charge going up at different points, but the force of gravity just going down at the center of mass.